So this video is for integrated 1. This is the classwork 8-66 to 8-68. This is page 51 to 52. So what we're doing is we're going to be taking a graph and trying to write it as an equation. Okay. So on this. For the first one here, it might help to look at these points and write them in a table. So we have a 0, 5. Now this point right here, we went over 1. So that means it's going to be a 1, and we went up 2. So 2 more is going to be a 7. So if I'm going to write the equation for this, this is going to be y equal, and my a is always my y-intercept, so 5 times b to the power x. And then I am going to put this point in for my x and y. So when I do that, I'm going to get 7 is equal to 5 times b to the first. Now b to the first is just b, so this is going to be 7 is equal to 5b. So when I work that out, my b is going to be a 7/5. So my equation is going to be y equal 5 times 7/5 to the power x. And that's the equation. On letter B, when I'm writing these points in, so this point here is a -1, 120. This point here is 0, 40. Now this is our 0, that's our y-intercept. So that's going to be our a. So it's going to be y is equal to 40 times b to the power x. And then we're going to take this other point, -1, 120, and put that in. So when I do that, I'm going to have 120 is equal to 40 times b to the -1st power. Now, when I have b to the -1st power, that is really a b on bottom, if I move it on bottom. So when I'm going to work this out, what I can do is I'm going to cross multiply is one way of doing this, where I put this over 1, and then I'm going to multiply 120 times b, which is going to be 120b. Okay, and then I'm going to multiply 1 times 40, which is going to be 40. And when I work that out, I'm going to divide by 120. And I get b is equal to 40 over 120, which can reduce down to a 1/3. Now, some of us might notice that if I'm starting with 120, I can divide by 3 to get 40. Now, when I divide by 3, that's the same as multiplying by the reciprocal. So some of us might have been able to see it that way. So our equation is going to be y is equal to 40 times 1/3 to the power x. On letter C, so on this one, I have a point here at 0, 18, and then we have a point here at 5, 18. So since I have 0, 18, that is going to be my a, my y-intercept. So I'm going to have 18 times b to the power x. Then I'm going to take this 5, 18 and put it in for my x and y. So I'm going to have 18 is equal to 18 times b to the 5th power. I'm going to divide both sides by 18. And so I get 1 is equal to b to the 5th. Now, when I take the 5th root of both sides, I am going to end up with the 5th root of 1 is really just 1. Now, if you're trying to figure out where the 5th root is on the graphing calculators. Let me show you where it is. So if you're using the classroom calculators, you're going to want to press this button that says math. And when you press math, you'll see that it is right here. The x root of anything, that's what you would do, okay? Now I'm just using a Desmos scientific calculator. There's a graphing one, but there's also, if you go to Desmos one, that is a scientific one. And so here is that nth root. So if I'm taking the 5th root of 1, you see that I do get a 1. And then our equation for this, let me get this back bigger. Our equation for this is going to be y equal, our a is 18 times 1 to the power x. Now, anything to the power x, 1 to any power, I should say, is really just going to be a 1. So if you're looking at this, you'll notice that this really is just a line. It is the line y equal 18. That's really what it is. But in an exponential type of a way, this is how it would be written. But again, we cannot have a base of 1. So this does clean up to this, which is a line and not an exponential graph. Okay, on D. Okay, so on D, I've got a point right here at 0,7. And I have a point up here at 3,56. So for this, I know it's going to be y is equal to, and I'm going to be using this as my my a. That's my a. So 7 times b to the power x. I am going to be putting in this 3,56 for my x and my y. So I'm going to have 56 is equal to 7 times b to the 3rd power. I'm going to divide both sides by 7, and I'm going to get 8 is equal to b to the 3rd. Some of us might know that the cube root of 8 is 2. But if you don't, then again, you would put it in the calculator to see what you get. And so when I put that into the calculator, sorry, just trying to get this cleared, it is going to be the cube root of 8, which is 2. So our b is 2. So that means that our equation is going to be y equals 7 times 2 to the power x. That is our equation. Now on this page, it says Earl and Sandy were working on writing an exponential equation, y equal a times b to the power x form using this graph. While trying to write the equation, Errol stated, I think a must be 10 because the y-intercept is at 0,10. Do you agree? Well, the y-intercept is at 0,10, and I do agree that that is our a. So yes, the y-intercept is going to be the a. But we still don't know what b is. So they noticed that when they put this in, they ended up getting this equation here, okay, this equation here. So since we know that it is y is equal to 10 times b to the power x, just like I was doing on the other page, they took this point here, 5,0032. So that's where they ended up with 0.0032 is equal to 10 times b to the 5th. How did she get this equation? So they put the 5 in for the x, and they put the 30.0032 in for the y. They substituted that in to the equation y equal a times b to the power x. Okay. So is it valid? Yes, it is valid. Yes, it is valid. Now, they want us to solve this, okay? So to solve this, okay, I'm gonna have 0.0032 is equal to 10 times b to the 5th. We're gonna divide both sides by 10. And so when I divide by 10, I'm gonna get 0.00032 is equal to b to the 5th. And we're going to be working that out. I'm just getting my calculator here. And so when we're doing this, what we're going to do is we're going to take the 5th root of both sides. So we're going to end up with the 5th root of 0.00032 is equal to b. So let me put it into this calculator here. Okay, so I'm going to be doing the 5th root of 0.00032, and we end up getting 0.2. So we get 0.2 is equal to b. So we know that our equation is going to be y is equal to 10 is our a times 0.2 or 0.2 to the power x. That is our equation. Use the values of a and b to write the equation of this graph. Verify that this equation is correct and explain how you did so. So here is the equation right here. And one way to check it is to put in 0 and see if I get out 10. So I get 10 times 0.2 to the power 0. That's going to be 10 times 1, which is 10. So that checked. And then to put in a 5, so 10 times 0.2 to the 5th, if I put that into the calculator, I do end up getting 0.0032. So it did check, it did work out. Now, they, in this next problem, say that the method that they use to write the equation of an exponential function with an asymptote at y equals 0 that passes through the points 0, 5 and 14, 4, 1, 2, 8, 0. So they want us to use that method. Okay, so to use that method that they used above, I know because this is my y-intercept that's going to be 5 times b to the power x. And then we're going to put in this point for my x and y. So 1280 is equal to 5 times b to the 4th. We're going to divide both sides by 5. And when we divide by 5, we end up getting 256 is equal to b to the 4th. We're then going to take the 4th root of 256, and let me just get the calculator here so you can see it. So when I take the 4th root of 256, we end up getting 4. So our b is 4. So our equation is going to be y is equal to 5 times 4 to the power x. And make sure you don't forget to submit this classwork.